Hello, my name is Daniel Crenshaw, and this is my lab run report. For this lab, we were tasked with charging two pieces of tape and seeing how they interacted with each other when put in close proximity. The main fundamental principle used for this lab was electric fields, their patterns, how they interacted with one another, and gravitational forces. While conducting the experiment, we discovered that two pieces of charged tape will repel against one another, indicating that they are of the same charge. Here's a video demonstrating the results. For this experiment, the system was the two pieces of charged tape, and the surroundings were everything else, including the table in our hands. The materials required were three pieces of tape, a table or stable surface to properly charge the tape, and a ruler or yardstick to measure the total difference in distance due to the repulsion. The initial conditions were the charge of the tapes were unknown/neutral, the weight of the tapes were 0.2 grams, the length of the tapes were 20 centimeters, and air resistance could be ignored regarding gravity. In order to conduct this experiment, we placed a piece of tape onto the table. We then placed another piece of tape on top of the initial piece and ripped it off in a quick manner. We then repeated this step, and finally, we placed the two pieces of charged tape in close proximity, one on top and one on bottom, and observed their reaction. We noticed that the piece of tape on top rose by approximately 1 centimeter. Here is the computational model. The blue sphere represents the tape on top, and the red sphere represents the tape on the bottom. The green arrow signifies the net electric field. The arrow pointing in the up direction corresponds with the rising of the tape on the top. Based on the computations done in the model, the magnitude of the charge of the tape is 4.96 e to the negative 9 coulombs, and to determine this charge, some assumptions had to be made. As stated earlier, we had to assume that the initial charge of both pieces of tape was 0. We also had to use our best judgment when dictating how far apart the pieces of tapes were both before and after the one on the top rose. Now, what if electrons had positive charge and protons had negative charge? Well, the simple answer would be nothing would change. Electrons and protons are just the names we give to certain charges. The only thing that would change would be the labels. Therefore, the objects in the experiment would react the exact same way, especially since they would still have the exact same charge and would repel each other. And finally, why is it important to handle the charged tapes as little as possible? What happens when the charged tapes come into contact with your hands or other objects? When we charge the pieces of tape, they only become charged for a short period of time as the electrons will travel between points of contact. So the more the tape touches our hand or other objects, the more quickly the electrons will travel and the tape will lose its charge. That is the end of the report. Thank you for watching.